All right, folks, let's get started here. Apologies for the delay, but we are ready to go. So good morning and good afternoon. Thanks for joining us from wherever you are. So today's webinar is Integrating Engineering and Design with RISA and SDS2. So my name is Alan Mitchell. I'm a technical sales engineer at RISA, and I'm joined by my friend David Zabka, who's a products manager at SDS2. So today we're teaming up to show you the new integration between RISA-3D and SDS2. We're really excited about this. So when we talk about integration, I think most people are thinking about architecture, working with architects and BIM modeling, that sort of thing. But we want to show you that there's just as much value in bringing your engineering and your detailing work together. So let's get started. So if you can't hear me, then you are not hearing this, and hopefully these folks can take a second to call in if they need to call in for their audio options. If you have any questions along the way, I see that a couple of you have already found the Q&A button along the bottom of the screen. Another one of my colleagues, Ben Follett, is online with us and will be watching for questions and answering them as we go. So since this is a joint webinar, we may have some folks who are familiar with one program and not the other. We'll just introduce ourselves and our respective companies real quick. Like I said, my name's Alan. I've been using RISA products in the design world for a little over 10 years. I'm a licensed professional engineer. I used to do a lot of steel designs and concrete designs for industrial applications. I came from the world of wireless telecom, so lots of steel stuff there. So doing this kind of platform work that we're going to look at today was sort of my bread and butter back in the day. David, you want to introduce yourself real quick?
Yeah, thanks, Alan. So my name's David Zabka. I'm with SDS2. I've been here for just over 16 years now. So I got my start here with the company as a support rep back in 2006, front line, taking all the phone calls, emails, everything like that to deal with, help customers with their issues, struggles, training, that type of stuff. And then, been in sales here for a bit now for about the last 5 years or so. So was in support around 10 years, sales for about 5 years. And now I'm in transition phase here to be the detailing and fabricating product manager for SDS2. So really get to be involved here now with the kind of vision for the future of SDS2. So I'm very excited for that. So
Awesome. Thanks, David. So the RISA product that we're going to be looking at today, I mentioned, is RISA-3D. RISA-3D, for those who aren't familiar, it's our Swiss Army knife, to use a cliche. It's all about 3D modeling for structural engineers. It is a multi-material program. We can design wood, concrete, cold form steel, and masonry elements. Obviously, today we're going to be sticking to hot rolled steel since we're talking about connection and detailing. You can do a little bit of anything in RISA-3D, but today's application of a steel industrial platform structure is definitely super common amongst our users. Lots of non-building stuff. It has direct integration, though, with some of our other products, including RISA Floor for those building designs, RISA Foundation, I think the name speaks for itself, and RISA Connection as well. So it makes the RISA product line a one-stop shop for many of our projects, but RISA-3D is definitely our most popular product, and that's what we're going to be looking at today. David, you want to talk a little bit about SDS2?
Yeah, so a lot of you probably know SDS2 from the detailing aspect, so that's really our bread and butter. But we do have kind of some offshoot products from that detailing product. So our SDS2 Estimating is a model-based estimating software. Load planning, that's something that we've recently come out with in the last several years here, really picking up steam with the fabricators. So that's a great product that uses IFC files to actually create each individual load of steel moving out from the fabricators. So pretty cool thing there. Model review. So for those of you engineers who are doing model-based review of the fabrication, shop drawings, you can do hybrid model where you're using the model and the shop drawings to do your review. Some engineers are really dove in head first to that and are just strictly reviewing the model itself and not even looking at drawings using that product now. So some really good stuff. What you'll see from me today will all be done inside of the SDS2 detailing. That's kind of our flagship product there. So everything you'll see from me today will be done in there, and all the functionality that you see would exist in that detailing product. So that'll be my main focus.
All right, very good. Let's jump right in. Let's start looking at a model. Not a lot of slides today. Let's get to the good stuff. All right, so here in RISA-3D, I've got a steel platform model that I've already put together. So again, RISA-3D is our analysis and design program. So it's really focusing on the member design, doing all the code checks for combined bending and shear and axial forces for this whole system. I've got this loaded up with some sort of equipment loads or degrading and wind loads, earthquake loads, whatever you need with this. And I've already got the solution run with this guy. So I can take a look at, say, envelope code checks and just get a quick, color-coded picture here showing that everybody is under 100% utilization. That's good. I can do all sorts of nifty things like view detail reports for individual members and get those code check breakdowns like I was talking about, all the steel bending, shear, axial equations that go into making sure that this platform is good to go. We have a lot of content about modeling in RISA-3D on our website and on our YouTube channel. So I'm going to focus on the things today that you might be specifically interested in as folks who are doing detailing work. So I encourage you to check out our other videos for just general overview of how to model here in RISA-3D. But for now, I'm going to skip ahead and have this guy already done and ready to go. So one of the first and probably the most important thing that I need to do with a model that I'm using for SDS2 integration is I need to change my vertical axis to the Z axis. So if you're familiar with RISA-3D, by default, the vertical axis is the Y axis. I've been told by my detailing friends that this is wrong, and civil engineers alike. So the debate continues, but we just go in here to model settings, axis, and change the vertical global axis from Y to Z. Done. You probably want to start modeling this way, but you can come back later and change it, and it will convert your data so that you don't end up with a platform sort of on its side. That would be bad. So vertical axis, Z direction, that's what SDS2 is looking for. So that's what we're going to do here. Second thing that isn't as common unless we're in the detailing world is to enable detailing options under application settings. So I go to File, Application Settings, and I go to, I think I already had it, Show Detailing Info for Members. So this is what this is going to give me. If I click on any old member here, I've got my properties along the left-hand side. And if I scroll all the way to the bottom, I have this extra box here for detailing. And this is looking for offset values and for cardinal point entries here. Now, I'm not going to go too in depth into explaining what we're looking at with cardinal point entries here. We do have, if I drag over our online help file, this is just available at risa.com/help, I believe, or if you go to the website, it's under support and online help. And then we have this entry here about cardinal points that gives you an overview of where every point is on any given shape, any odd shape at all. So take a look through that and just use that to your advantage if you want to set up your detailing information a little bit ahead of time here in RISA-3D. Not necessary to do, but it is an option that is available to you. Some other questions that I've gotten from folks about what we can and can't do when we're going into SDS2. One of them was about RSA loading or response spectra analysis loading. Can I have response spectra do a dynamic analysis for this model? The answer is yes. If I go into my load combination spreadsheet, I'm solving this model for various wind loads, seismic loads, things like that. And you can see down here, I do have response spectra analysis included in this model. it really is only looking for member end reactions. That's kind of the name of the game here when we're using the integration with SDS2. That's all it really cares about. It doesn't really care where those end reactions came from, as long as they are there. So yes, use a dynamic analysis to the fullest extent. One thing I don't have in this model, but I've seen it in some other models, is partial fixity for the I and J releases. So, I have just typical pinned end releases for all of my members here, but we do have the option here in RISA-3D for partial fixity. If I use custom releases, I can basically put a sort of a spring constant here that allows that member to rotate. And then, it is going to behave as a pin, but it's going to generate that moment reaction based on the partial fixity value and how much it is deflecting. So again, that's just another reaction that gets generated. It's going to generate a moment reaction. And we would just say, pay attention to that and know that that's being generated by the system. Another similar option is, well, not too similar, but another option I've been asked about is analysis offsets. So this is another way, kind of similar to the cardinal points feature, but it does have an effect on the analysis. If I look at the center line of this beam that I have highlighted compared to the center line of this beam, we can see that the analysis line, I've put it at the top here by doing an analysis offset. So useful for getting something, top of steel, all aligned, things of that nature, as opposed to everything being modeled on center lines by default, which is what we kind of see over here. Again, you can do it. It does affect how, forces are distributed in that member because of the offset. So again, just pay attention to your end reactions and what's coming out of the program, and you'll be good to go. The last thing that I was also asked about was member end offsets. So this is a way, if I look at this highlighted member here, let me just hide everybody else for a second. This member you can see has member end offsets that I've entered in on the properties panel over here, an offset of 12 inches. What this is essentially doing, we can see with this sort of dark gray section at each end of the member, it's basically inserting a rigid link and offsetting the actual start and finish of that member, despite it still being connected to this node over here. That can be useful for if you have a really, say you know that you're going to have a really heavy duty connection, you've got some really stiff gusset plates that are coming out 12 inches, and you really want the member design to sort of start and end accounting for that offset. We can do that too, no problem. So the things I keep mentioning though is that they are going to create some different reactions. There are going to be different small moments that get generated, slight differences in loading, but there's a way to accommodate that when we input into SDS2, and David's going to talk about the threshold values for when you bring this model in to SDS2, and that's just something that you can use to account for any of these tools that you're using, the offsets or the analysis offset, all of that stuff. All right, so one last thing that I want to point out, something that was pointed out to me in a webinar about delegated connection design a million years ago, and now I'll pass it on to you folks, is that we're talking, or David's going to be talking a lot about how a lot of the value that this adds to your project is that very often we're designing connections for just the ultimate distributed load that a member can handle, or some other factor that's going to give you a very, very conservative and a very heavy connection that's going to just cost a lot more money. So by using this integration and using the actual member end reactions from these members, you're more often than not going to be designing, more accurate, more efficient connections and saving some money in your project that way. The flip side that does occur once in a blue moon that I was warned about a million years ago is a situation like this, where say I have a very heavy point load right on the end of a beam, something like this. Really heavy point load that, this beam is fine, it's well within its code check value, but this point load might create an end reaction here that is actually greater than what I would get if I were just using the uniform or the ultimate distributed load method. So every once in a while, if you get some sort of an odd framing situation like this, or just a whatever that generates a really heavy shear load near the end of a beam, might be something to watch out for, that, doing the usual method might actually under design your connection. So that's just another great way that, value is added to the project, both in terms of efficient connections, but also accurate connections and covering all of your bases this way. All right, so I'm just about done with this model and ready to hand it off to David. The last thing that the name of the game here that I'm looking for is these envelope member end reactions. I've got every member in this system has all of their minimum and maximum end reactions for all 6 degrees of freedom in this big old table. And this is basically what I need to do to get my design over into SDS2. Pretty simple at this point. One important note is that I have solved either an envelope solution or a batch plus envelope solution, because these are going to be envelope results that are sent over to SDS2. So that's easy enough. I've solved a batch plus envelope solution. I get the best of both worlds. When I'm happy with this design, file, export, SDS2 end reactions. And it's going to prompt me to create a text file. You can see I already created it because I was testing it. And it's just creating a text file of those member end reactions right in the same place where you have your RISA-3D model file solved. So I hit save on that, and I'm good to go. That's all I need for the RISA-3D portion of this integration. Pretty normal stuff from the RISA-3D side. Not a lot of things, not a lot of additional work that you need to do with your typical design. So if just to recap really quick, let me switch back to PowerPoint. So on the 3D side of things, to get set up, you're just looking for your Z-axis in the vertical direction. If you want to do some cardinal offsets, use some cardinal points, you're going to show detailing info under File Application Settings. Solve either an envelope or a batch plus envelope solution. And then as simple as that, file, export, SDS2 end reactions, and we are done with the RISA-3D model. So with that, I will hand it over to David if he is ready to go.
Okay, thank you, Alan. So bear with me while I get switched over to sharing my screen. And hopefully I did this correctly. You ought to be able to see my SDS2, the main menu here, open.
Yep, you're good to go. Yep.
Perfect. So main menu, this is a brand new project. I'm going to go ahead and launch our model. And you can see I've already created some views within this model. So I'll open an isometric view. And now what we're going to do is we're going to take the R3D file. We're going to import that R3D file. That gives us all the member geometry, section sizes, point-to-point input, all that. And then we're going to combine that. At the same time I import that, we're going to import the text file that Alan showed that you can export from RISA by hitting the SDS2 end reactions. So that gives us all the geometry comes from the R3D file. All the end reactions come from that text file that we create. Now, this tool is a plugin to SDS2, so it was developed using our API. And we do host this tool on our website, so sds2.com. We have a toolbox area that you can download this and install this for SDS2. And then you have the choice of placing that anywhere on your ribbons under whichever tab you choose. In my case, I chose to put it under this import-export tab, and we have the RISA import. So again, I mentioned we're going to pick our R3D file. So what file do I want to import? And I have this out here in this folder here. We have the industrial platform. And then I'm going to select the corresponding text file to go along with that. So we'll go here. And then we talked about the thresholds. So Alan talked a bit about some of the different loading conditions, things like that. what we found is many times there can be some really small results for different loads within that text file. So we just give you the ability to determine, at what point do we want to ignore those loads? So anything less than what we have in here would be ignored and wouldn't be applied within SDS2. I'm going to actually lower the shear load threshold down a little bit to, I'm going to actually go 0.001. The reason for that is it just, you end up with some kind of odd results sometimes, if you will, when we get a zero shear load that's imported. My axial load, I'll leave that at 0.1. You can see we're indicating the units that we're using here. So those units aren't going to match the units from your R3D file. These are hard-coded here currently to KIPS. We will do the conversion. So we read it in and we do a conversion based on the units that are specified in that R3D file to apply them correctly to SDS2. Just within this window, know and understand that you're entering your values here in KIPS. And then the same with the moment threshold. This particular threshold is always going to be entered here in this screen in KIP inches. Again, we do the conversion on import appropriately. We just need to enter that appropriately here. And then we have options for moments. So where a moment is present, how do we want that done? So welded moment is going to give us a direct field welded moment. Bolted moment is going to give us bolted flange plates, or we can choose to not set that moment if we want. And then we get our moment connection. What type of moment do we want? I'm just going to leave everything here with the defaults at that point. I click OK. And what's happening here now, I get this, and the screen is going to, I wonder if I can move this screen. Sorry, bear with me. Okay, there we go. So this is asking for a substitute. So within SDS2, we have what we call a shapes properties. This is like a big library of all my section sizes and all their properties. When there are sizes within our R3D file that we don't recognize, we're going to be prompted for a replacement. In this particular case, I've gone through this model a couple of times ahead of time, so I know that these sections, I believe they're in a section set or a design set within RISA-3D, but they're not actually used within that model. So as we read it, we see them. I know they're not used, so I'm going to cancel this, but I could also browse and select an actual replacement for that within SDS2. Okay, and then you can see our model being built as it's reading that file. And then here we're going through a process where we are designing the connections, creating the solids, and even going through piece marking routines to apply piece marks to everything in here. So we see we get that same model that Alan showed us within the R3D side of things. And, you know, there's a couple things to point out here, a few things to mention. You know, if I double click my beams here, and I have a couple screens open, so slide my edit window over, we can see within the load section for the end reaction. So we can see we're importing a shear load here of 0.6 kips. Our tension load is 1, compression load is 1 as well. And let's go ahead and have a look at a couple other things. So I do have a setting set up here that's going to change things, make it difficult for me a little bit. So, you know, one of the great things with SDS2, if I come out to these project settings, is we've collected a number of different settings that satisfy fabricator needs to make the fabricators as efficient as possible with their connection design. So we've collected those over the years and incorporated that into the way that we design connections. So you can see there's things in here stuff like keeping shear plates symmetrical when we design those shear plates. So that prevents fabricators from installing the shear plate backwards. Just simple things like that that we incorporate into SDS2. So I want to go to my design, into my design settings. So you can see we have our connection design method here. We can design these to ASD, LRFD. We have the Canadian code and a few others in there as well. I'm going to turn off this minimum setup connection box that we have set there. And something else to point out with our connections is we have what we call auto standard connections. So what this is, it's a big table, has all ton of different framing conditions within here. So if I were to scroll down and look at maybe say the, let's go beam to beam. And if we look at the wide flange beam to wide flange beam framing to the web perpendicular, if I double click that, what we see is we see the connection types. We can do clip angles, bent plates, end plates, shear, number of different things there. And then on the right, we have kind of the different variations of that. So is it bolted? Is it welded? We could see this one's going to be set up. It's going to be just a single-sided clip angle, welded to the supporting member, bolted to the support head member. Okay, so I just have to go in here. I changed that setting in the setup. Remember, I unchecked that minimum setup connection box. So that will allow some of these connections to be designed a little bit better than what we saw there initially. And here we go. And it's not going to cooperate with me here. So let me just have a look in here at what's going on. Some reason it's not liking the axial load that I have. So let's just go ahead and try setting this from auto standard to a clip angle connection. Okay, so that works a little bit better. I believe there's probably an issue with the way that I have my clip angle, those auto standard connections set up. So what you can see here is we designed that connection. We used the loads that were imported. So the 4.9 kips, the 1.7 tension, 1.7 compression. Now, one of the things that Alan mentioned was he discussed the 50% uniform allowable load. So SDS2 can calculate that. And I can check that box onto auto here for the shear load. Notice it's going to change that from the 4.9 that we had over to 24.7 and design this connection for 24.7 versus the 4.9. Don't necessarily notice in this case a difference here just because of the welded connection there. That's a pretty strong connection. So in this case, you don't necessarily notice it, but you start getting into some bigger, heavier connections, bigger bracing connections, things like that. Just that blanket percentage can really increase the size of the connections, you know, start requiring doublers and stiffeners all over the place. And when we start doing those types of things, really increases the cost to our connections. So one of the big benefits, again, of importing these end reactions from RISA is you're sharing that information directly with the detailers and the fabricators creating the fabrication model. We're going to get a lot more economical connections typically using the actual design results versus a generic kind of blanket load. With these connections, we provide all the AISC checks. So if I click the expanded calc button at the bottom here, this is going to print out a PDF for me. So it's generating this PDF form. And again, I have Bluebeam up on a different monitor. So I'm going to drag that over to show you the design report. There we go. So in here, we get some basic information about our members. We see we've got a W10 by 30. We've got our different section properties laid out in here. We have information for both the left end and the right end, kind of what's being designed there. You can see the input loads, that those are the loads that were imported. And then we get into the each individual end. So this is the left end of my member. We can see it's telling us what we're framing to, what the size of it is, elevations, all sorts of information in here necessary for the documentation we need. And then we get into the actual connection details themselves. So, angle sizes, weld sizes, bolt sizes, spacings, all that. When we get down a little further, we're going to see the allowable strength summary for that. So we're indicating the check that we're performing. This calculation number we see here, that is from our cover sheet, which is a separate report from SDS2. We have our unity ratio, we have our actual result, and then we have the AISC reference where we're getting the information and formulas, checks that we need to do there. Everything's bookmarked really nice. So if I expand the bookmarks over here on the left, we can see lots of bookmarks in here. And then I can even go to the expanded design calculations for this. So this is just going to expand on all the checks that I just saw in that design strength summary table. This is going to give us the actual numbers, all the longhand calcs formulas that show how SDS2 actually arrived at the result that it did for each one of those checks. So everything is documented very clearly, very thoroughly here for us. Okay, so a couple other things to take note of. I do have some orientation problems here with my braces. I do see that. Another thing to point out here, one of the things that I always stress is really good modeling practices, right? So you can see here in this model that these are shown as horizontal braces. Not going to give you the best results. That may work great in RISA and fine in RISA. Within SDS2, we need to categorize these a little bit better as vertical braces so that it understands a little bit more what those are, what purpose they serve, and so that it can design the connections appropriately. Now we do have some kind of what I call post-process tools to help with that. I can select those members, and then we have a utility here to change the member type. Now, this does pose a set of problems for us just because as they're imported now, you can see I've got my tension and compression loads applied there. When I run this change member types, the way this all works, it's not going to be able to maintain the end reactions that were imported. So I'll run the member change type, and I want to change that to a vertical brace. Now, I don't know if they're all the same. I didn't look at all of them, but I'm just going to go ahead and do an edit here. You can see the end reactions. Now we're not seeing the same we did. Like I said, we can't maintain that when we change the member types right now. So what I would stress in cases like this is do your best with good modeling practices in RISA-3D. Call a vertical brace, call a horizontal brace, and that's going to make everybody's life a lot easier, a lot better results downstream as we go. So the other thing you'll probably notice here is, so we get some pretty large gusset plates there, right? I'm just going to turn everything to a stick form and show us and point out a couple things here. So the work point for those braces are at the top of steel of the beams. So, design and analysis, whole different animal versus detailing and fabrication. So, typically for those of you doing the analysis and design, you're going to be working at the centroid of those members. Detailing fabrication, a little bit different. We're always concerned with that top of steel. Things translate into the detailing and fabrication model slightly different. We know that. And again, we give you kind of a post-process tool to help with that. So what we do is we give you this nice little tool that says change the vertical brace work points to half nominal depth of the beam. So it tells us, hey, this program is going to modify the elevation of the vertical braces. Yeah, I want to continue with that. So it's going to go find the braces, going to figure out what they're framing to, adjust their work points down half the nominal depth. And now you can see the stick lines are now no longer at the top of steel. They're going to be at the half depth. Okay, so a couple of other things to point out here then with those vertical braces. We are using the uniform force method to design these connections. So what you're going to see when I double click the beam, not only do we have the end reactions applied that were imported from RISA-3D, we also get the gusset interface forces indicated to us here that are caused by that vertical and horizontal component of the end reactions on the brace. They're being accounted for in our beam connection. And if I go back into my project settings, just to give you an idea, again, a little bit more of the flexibility and how we do things here. So if I come into my braces, you can see we do have the option to automatically add those forces to the beam. I do have that checked on. And then we can handle any special case that's outlined for that as well. Special case 2, 3, even the modified working point special case will handle if that working point is not along the center line of your column. So a lot of flexibility there as far as how we're doing the transferring and design of the bracing connections as well. So, and then from here, you know, you need some documentation, different things like that. So that's probably actually a really good connection for me to show this on. So, you know, one of the things that we focus on with SDS2 is, can these things be fabricated? Can they be erected? So in order to really focus on a lot of that stuff, you know, we don't just design one connection to a connection for one member to another member. We're really looking at that whole joint when we design that to make sure things can be erected. And you know, over here is a good example. Simple form of that. We cope out those beams appropriately based on fabricator settings and then AISC checks and whatnot as well. And then over here, we're kind of designing this as one whole joint, one whole node. So we want to be able to document that as one whole joint or one whole node as well. What we've done for that, we've come up with what we call these connection cubes. So this kind of lumps, instead of running the expanded calc like I showed you before, where I ran it for one member and I got all the documentation for both connections of that member, this is just going to give me the documentation for the two connections that I picked. I can give this connection cube a name. So I'm going to call it double angle brace at beam to column. Okay. And then I have options of different things I want to actually include in this report. So I can do a schedule minimums. I can do a 2D detail. I can do a 3D format, my strength summaries, my expanded calcs, cover sheets, number of different things in here. So this is just a way to kind of refine what you want included in that calculation output a little bit. And it lumps the two connections that I picked there together versus generically giving me the left end and the right end of a member. So again, that gives me a PDF. So I'm going to actually get some 3D information within this PDF. So Where this is great, especially in Bluebeam, when I look at my model 3D model tree within Bluebeam, I can pick things in this 3D file PDF portion of this, and it actually drills down and gives me, you know, sizes, types, lengths of bolts, plate sizes, everything in there. But then when I start scrolling down a bit again, oops, there we go. So then we go directly into our allowable strength summaries, same table we saw before. Strength summaries for the other connection that I had included on there, get into some notes, and then, so it's all just organized a bit differently than what we saw. So a little bit cleaner, less information, more specific to just what I'm after here. So this is great, especially for those of kind of maybe the junior engineers doing this design, needing to get approval from the EORs, the senior engineers. We can use this, take this, that 3D information that we can include in here is invaluable for visualizing and being able to get approval on this before we go ahead with our actual construction documents and such. So great stuff there. We can even turn these off. So if we don't always want to see these big giant connection cubes everywhere, we do have a checkbox in our display options to just temporarily hide those things. So then, you know, SDS2, we're full on detailing package. So, you know, on top of importing the structural members, just to kind of give you an idea, some of the things that we do, you know, miscellaneous steel, different stuff like that. I've kind of laid some of this out ahead of time just to show you. But, you know, we have different tools within here to kind of finalize all the miscellaneous portion of the structures as well. So what I'm going to do in this case, I'm just going to add a handrail all the way around this platform here. Okay. So I'm just picking my points here. Now, I'm doing this all kind of in one layout, one shot. But what's great with SDS2, this particular tool, is it's going to give me another screen here that asks some different constraints about my railings and how I might want those to be detailed and fabricated, max lengths, things like that. So it's going to actually split those rails up based on that layout and the constraints that I put in here. I'm going to choose to do a shear tab to connect all of this up. Okay, so it's going through, you know, we create these rails. Everything is done to fabrication standards. You know, all the pipes are going to be fit together, everything like that. We've got elbows, I think is what these rails will be set up. Excuse me, I actually did set these up to be mitered, but we can do elbows there as well. Pickets, all sorts of stuff. I got my toe plate on the wrong side. That was user error, can't ever fix that. But you can see when I highlight these rails, you can see each one's its own individual handrail. It was split up based on those constraints that I showed you there. So, and then we get into detailing everything then as well. So if I want to see the shop drawing for these handrails, I can tell it to show me the detail. It's going to go through. It creates 2D views, and then it will dimension, add labels, weld symbols, all sorts of stuff that we see here, a full bill of material. So we can really get the full package for our detailing and fabrication that we need. And then same thing with the beams, the braces, everything that was designed over here. So if I grab one of those beams, tell it to show me the detail. And I'm just doing these one at a time here. Keep in mind with SDS2, I could do the whole building. I could I could detail up a whole sequence if I wanted to. I don't necessarily have to do them one by one as I'm showing you here. But that's the way I'm doing this particular one. So everything in here is click and drag, add our own dimensions, all sorts of good stuff like that. And then what we would do kind of for the final product, we can place these on a sheet outline that actually includes a bill of material directly on it. Okay, so there we get my beam placed on the final sheet, and then we get our bill of material information populated directly from the model and the materials that were attached to that in the model. I can do revision charts, title blocks, company logos, all that good stuff here, fully customizable. So, that's so that's kind of what I got for us, Alan. Hopefully that was very informative. Hopefully I didn't miss anything, but I think I'll turn it back over to you now.
Yeah, well, we've got a couple of minutes, and we have a couple of questions in the Q&A if you want to take a look at those and see if we can answer them here in the last little bit. I'll start. There was a question from Zach about the difference between SDS2 and RISA connection, which I can. David laughs. So both SDS2 and RISA connection integrate with RISA-3D, which is great. They both do calculations and get you a full calculation output for different connection types, which is also great. But that's sort of where RISA connection ends and hands it off to SDS2. There's just a lot more tools specific to detailers and fabricators for SDS2, obviously here. So, if you're looking to create what we're looking at here, shop drawings for a handrail, bill of materials, all of that good stuff, that's all SDS2 all day. So yeah, I hope that answers your question.
Yep. Yeah. So it's just we take a little bit different approach as well with our connection design. So with SDS2, what we do is you give it the end reactions. We come up with a design and do the checks. But we do also still give you full control to give it your own design, so you can plug in your own variables about that connection as well. So, yeah.
Let's see, there's another question about is LRFD design available in SDS2? Yes.
Yep.
Good eye.
So we do,
yep.
Yeah, both ASD, LRFD. We have the CISC also for the Canadian code, and a couple others. We've started developing some more international codes here more recently also. So.
Okay. They're reviewing us on the fly. I did my model in LRFD, and you did your connections in ASD. So we might need a good review here.
Yep.
Somebody will check our work. Good eye.
Yeah. So there's one about. I'll just pop in here, grab that. So does SDS2 generate NC1 files for the beams? Absolutely. Yep. So your NC1 files, to work with the machine integration into the shop, whether that's a drill line, beam line, Python X machines, Vortman machines, all that. We've been doing that for a long, long time and have a good relationship with all those machine manufacturers that we work with pretty closely. So. And I'm going to go ahead and take that top one there too, Alan, about the integration between RISA and SDS2 being set up to round trip multiple times or just a single time. What we're doing right now is this is just a single one-time transfer. So the round trip thing is, in theory, it's a really great idea. In practice, it's difficult because detailers are very, very particular about their models, right? So it can't be close in a detailing and fabrication model. It has to be exact, because that's what everything is being built off of. Hence the nature of the detailers being very particular about their models. They need to know what they have is exact. So currently what we've done is we've set this up to be a one-time transfer. What we're going to work on here with improvements is doing an update to the SDS2 model, not for everything, because the detailer doesn't necessarily want everything updated. So we would be, as we develop the update, it's going to only update certain things that the detailer would want to allow a blanket import to update. So end reactions would be one of those things, so that we get accurate connections based on any changes in the design. So we're working on it is the short answer for the round trip.
There's a question about, can we do the reverse? Can we model in SDS2 and push that model into RISA-3D to do our checks? I believe the answer to that is yes. And the platform that we did today actually started that direction. If I'm, correct me if I'm wrong, David, but the that was modeled in SDS2 and sent to me to play around with in RISA, and then we sent it back to SDS2. So,
yes. So what I did there, I actually created a model in SDS2. I exported a CIS2 file and used the RISA has their CIS2 translator that converts to a R3D file. So that's how the model actually started. And then I let Alan do all the loading and such in R3D before taking that back with the end reactions.
And that SIS2 translator is a free utility that's available on our website, on RISA's website. And I threw some mistakes into the model just to see if David would catch them.
I'm sure there's ones that I didn't catch also.
Let's see if we go ahead, David.
So, well, I was just going to maybe touch on, there's one about SDS2 models into Revit. So SDS2 does work with Revit. We would either export an IFC file, so generic IFC file. We do also have a plugin specifically for SDS2 and Revit. Again, you can get that from our SDS2 toolbox on our website. And that's a plugin inside of Revit that allows you to import. So.
And I think we answered the question that if we modify the RISA-3D model, can we update the SDS2 file with the updated results?
Yep, I believe we answered that one. And then we also answered the reverse-like model in SDS2 and do the check in RISA-3D. So that's, again, done with that SIS2 translator is the way that it would be done.
So the last one, does SDS2 connection design all types of shear, moment, and brace connections, including base plates? And are there any connections that it has that RISA connection does not? The second part of that question, yes, there are many more connection options in SDS2. You do have a lot of freedom in there to do just a lot of different connection types. RISA connection does have an extensive list that you can find on the help file on our website. It's one of the first help file articles. It's available connection types, and you'll see that it's a list of primarily common building design connection types, just shear tabs and clip angles and things of that nature that you would find in a typical building design. So it's great for integrating with RISA Floor and RISA-3D to do building design. And then for things like we looked at today that are a little more industrial, SDS2 is going to have a lot of options for that.
And I would just mention on that, just to answer one specific portion of that question about the base plates. SDS2 does not do the base plate design today, unless it's in a maybe cantilevered situation or a column framing on top of a beam, we will design those. But if we're talking a column just sitting at the foundation, we don't do that base plate design today. So,
and RISA connection actually does have that one, so we've got you there.
They're perfect. Yep. So again, and just to elaborate there, does SDS2 include any concrete checks related to base plate connections? So we're not, SDS2 is not doing any connections there at the concrete. And then 2 questions there. So connections preset when you export the model using only member types. I think I showed the table, the big table in SDS2, where we had all of our different framing conditions, beam to column, wide flange to wide flange, and then we set the connection type that we want designed specifically at those different framing conditions. And that's how SDS2 was determining the connections to design. And then, so that's going to kind of give us our overall. And then we do have the ability to change on a case-by-case basis if we want, say, a shear plate instead of a clip angle or whatever might be the case there. So we set our overall on our project settings and then change on a case-by-case basis. So, and then do we consider the 341 requirements? So today, SDS2 is considering the requirements for the, I believe it's the bolted flange plates in that case, but those are the only ones that we're checking today. I'm sure we'll continue to, enhance those and add more of those checks as we go here. But today we're just doing those checks for the bolted flange plate moments. So.
All right, folks. Well, that's our time for today. Thank you all for joining us. We will have PDHs sent out, I believe, at the end of this week or early next week. We will also have the recording of this webinar posted on our respective websites, I believe, so we can go back and see anything that you might have missed. Please feel free to visit our website, either of our websites, where you can schedule a one-on-one software tour with myself or David or one of our other experts to discuss how our software can suit your specific project needs. Feel free to contact us directly as well. We've got our email addresses up on the screen here for any questions that we didn't get to today. And yeah, we can answer them at another time. So thanks again, everyone, for joining. We appreciate your time and hope you have a great rest of your day. Thank you.